ways are there to solve math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is
2 times length plus 2 times width.
Good afternoon and welcome to Count on Us, the show where you are the stars. You're going to call in with those math questions and you will ask me, Mrs. Jennerette,
or me, Mrs. Jax.
and we are here to help you with your homework needs. You know you can reach us at 301-772-0080, and momentarily that number will be at the bottom of the screen.
There it is.
301-772-0080. And you can watch us on Comcast Channel 96, Verizon Channel 38, or the World Wide Web, PGCPS.org. Click on Communications and you'll see the link for Count on Us. Okay. So, happy Monday.
Yes, happy Monday. How are you today?
I'm great. It's not raining.
I know.
The sun is out. I had to wear sunglasses.
Nice.
Yes,
the weather
it is
nice. Speaking of, okay, I took mine off. All right, so as Mrs. Jennerette said, you may call us with your homework questions or any type of math problem that you have, and you are the star of the show. Remember when you call in to turn your television all the way down, so the only way you can hear us talking is through the telephone. We don't want to get any feedback.
Yes.
But we're going to give you some information about Count on Us just in case you are a first-time viewer.
Okay, well, we have some problems also for you to attempt. And when you call with your question, a math question, a homework question, a question about a quiz, we'll work it out with you. And then if you would like, you can do, not if you would like, you are going to do it. You got the word of the day, and we have our 24 challenge. And those of you that call with your homework question, you get your name in our treasure box. And if you do our word of the day or one of our 24 challenge cards correctly, you get 2 names in the box.
2
And then at the end of the show, a lucky winner will be picked out of our box and you will receive a prize.
All right.
And our prize today, I think, is, oh yes, and I shouldn't say because I'm so hungry, those delicious Domino's Cinnasticks. I'm so hungry, so the one that wins that today, I'm so jealous of you.
That sounds good right about now. Let's talk about how 24 works, just in case you haven't seen it before. So if you would look at your screen in just a moment, it should be up there, and we will discuss how to do the 24 challenge. There it is. Okay. So the way this works is you have 4 digits, and the object of 24 is to get a sum or a product or a quotient. Your answer has to be 24. Okay, and I said sum, product, quotient, difference, because there are 4 operations that you can use in order to get 24. Now, you don't have to use all 4 operations, but you must use all 4 digits.
Can I use a digit twice?
No, you may not use a digit twice, Mrs. Jennerette.
Okay.
That is a no-no. So let's look at card A. Card A, the digits are 1, 8, 8, 4. Now, Mrs. Jennerette did ask if she could use a digit twice. 8 is listed here 2 times, so that means you need to use 8 twice, but you can only use 1 one time and 4 one time. All 4 of these digits need to be used in order for you to get a total of 24. And once again, that can be a product, it can be a difference, it can be a sum, or which one? Or a quotient. Okay, so if you use one of the operations or all 4 or just 2 or 3 operations, it doesn't matter as long as you get to 24.
And then we have another card, card B, and the digits are 1, 5, 4, 7. And card C, I like this one. This is a 6. 6, 6. We have 2 6s, so you can use a 6. You have to use this 6, a 5, and an 8. And card D is 3, 7, 684. So when you call in, you will tell us which card you want to use. Please make sure you work it out before you pick the card. So just we can speed up the time and give someone else another chance. So make sure you write these numbers down. And then once you have them written down and you have the solution, call in with your math homework question and you can pick one of these 24 challenge cards.
Mrs. Generette, I have a question about this. How did
Yes.
you know? I see that this one is clearly a 6, but what about this? How do you know that that's not a 9?
I know this is not a 9 because the 9s on the 24 cards have the circle filled in with red.
Oh,
So,
okay.
and actually it would be turned around because the red would be on top and the red circle means a 9.
Oh, okay. So that's good to know. So once again, these are 6s. And when it's not filled in with red, then the digit is 6. If it is filled in with red, then the digit is 9. Okay.
And you know, everybody loves 24 Challenge. I love 24 Challenge. But we have another activity for you to attempt. And I love this one. It's called Word of the Day.
Ooh, word of the day.
You don't know what the word of the day is. So what you would do, you would ask me or Miss Jax a question. We would either say yes or no. And then if you want to guess the word, let's say you think it's sunshine. No, the word of the day isn't sunshine. Just keep in mind that our word of the day is a mathematical term. So whatever the word of the day is, I think we provide a clue, one clue, and then based on that clue, you either ask a question or guess the word.
Okay, so we know it's definitely a mathematical term, like you said. Do we give the clue ahead of time, or do we give a clue when one of the students calls in and asks to do the word of the day?
That is a great question. I think we should give the clue when they call.
Okay, so make sure when you call, and 24 Challenge is very popular.
It
but I
is.
like what Mrs. Generette said, the word of the day, this is fun. And you get one guess, right? Is that
One
true?
guess.
Just one guess.
One guess. And if you get it, you get another name in our treasure chest. But if you don't get it, that's all right. You may be able to call back in and try again, but we're going to see who can guess the word of the day.
All right. So don't forget to call us. Look at the bottom of your screen. The number is 301-772-0080. We know that you all have been taking different tests. I know the science test is going on this week, and next week you all may have a test as well. So call us with your math questions. I'm wondering if there were any mathematical problems on the science test.
Oh, I bet you there is, because
sure
math
there
and science are a wonderful, wonderful way to see where math is everywhere. It's not just something you do at your desk or something that you do because your teacher asks you to. Math is everywhere, science especially. So I'm sure there were some math questions on that science test. So call in, see if we know.
That's right. Okay. All right. Well, while we're waiting for our phone calls to come in, there are a couple of things that we can discuss.
Yes.
Mrs. Generette, are you familiar with the 8 mathematical practices?
I am. Everything's my favorite, but it's because I love math. But I love these mathematical practices. These are the habits of mind that everyone, adults, 5-year-olds, 18-year-olds, these are what you go through when you solve a math problem. And the first mathematical practice, make sense of problems and persevere in solving them. Oh my gosh, that's a lot of stuff.
That is.
What does that mean?
I'm looking at make sense, meaning that you need to understand it. But this word persevere, what does that mean?
Persevere. Well, I know a lot of things just in life in general are difficult. You don't have an easy answer. But we can't just quit as soon as we read it and say, oh, nope, I don't get it, so I'm going to move on. So what we have to do, we have to persevere. We have to think, and we have to struggle, and we have to explain, and we have to reason. And on our mathematical poster, we have some things, some strategies to do before you solve a problem, what you do during, and then what you do after to make sure you persevere and actually solve a math problem.
So I shouldn't just try a problem and then give up because I don't get it the first time?
Nope.
What if I'm working in class and I do it a certain way and then my seatmate or someone at my table mate does it a different way? Is there only one way to arrive at a problem when it comes to math?
No, that is the other reason why I love
okay.
mathematics. Math, it's so many different ways to solve a problem. And before you solve a problem, you need to really think and explain the problem to yourself. What is this problem asking me to do? You can organize the information. You can look and see, am I putting things together? Am I taking it apart? What information is not giving? What other skills do I need to have in order to solve the problem? This is what I do before I solve it. And then when you think about it, you can come up with 3 or 4 different things to do.
Okay. So after you do the before, after you think about it, after you try to understand, you know, what the question is asking you, then you would go to the during stage. So you would actually try the problem then?
After you've thought about it, you came up with a reasonable strategy.
Okay.
Now let's do it. Let's persevere. I'm going to work through those algorithms, and if I don't understand that algorithm, I'm going to make a model. I'm going to draw a picture. I'm going to monitor and check to make sure I'm precise. And if something doesn't work out, perhaps I did an estimate, and my estimate said 500, but then when I did the work, I came up with the answer 2. Oh, then my first plan didn't work. So what I need to do is go back and see what happened, what went wrong. So sometimes during that phase of solving the problem, you have to change. You have to figure out, that didn't work, that doesn't make sense. And that's one of the most important things you can ask during a question. Does this make sense?
Okay.
If it doesn't make sense, it's all right. You know how many times I've done something and it just didn't click and I had to, let's try it again. Let's try it a different way.
Well, that's good to know that, you know, you're not always going to get it right the first time. There may be times that you do get it right the first time, but the fact that it says persevere here means that I have an opportunity to try several different ways. And if I don't get it right, I can change something.
Yes.
That is great. That's really good to know. So I wonder what I do after. What's the last thing that I would do?
Well, after you've gone through, you made sure it made sense, go back and ask, does my answer the question? Is it correct? How do my representations, if I did a drawing, if I did a model, do they match my algorithm? This is where I check to make sure I'm precise and I'm accurate.
Okay.
Then you just reflect. What strategies were really helpful? What strategies, and next time I have a problem, I'm not going to try it this way because I found out it took too long. It wasn't effective or quick. And hey, 50 million ways to do something. Maybe my classmate did it a different way. I'm also going to evaluate others and see how they approach the problem. Oh, I didn't think of that way. So it's just so many things your mind goes through when you go through a problem. It's not always about getting the answer done quickly. It's about the process and sticking to that accuracy. Does it make sense?
Okay. All right. Okay. Well, that was definitely number 1 for our mathematical practice. And it says to make sense of problems and persevere in solving them. So there are 3 different steps. Once again, there's something that you do before you even attempt the problem. During the problem, you definitely want to take your time. You want to try again. Don't just give up the first time. Monitor your work. Make sure you're following, you know, what the question is asking. Change it if it doesn't work. And then ask yourself, does this make sense? If it does make sense, then you want to make sure you check. Often students are so excited, oh, I got it right, you know, this makes sense, or I did it. And then sometimes they don't go back and check. So you definitely want to make sure that you check. I know I worked with a group of 3rd graders today, and the question was asking the students to find the number of pieces of paper at a table. So they used the information in the word problem. They did find out that 24 divided by 6 gave them 4, but the question wasn't asking that, you know, so sometimes when you have a word problem, there are numbers involved and, you know, you can do the arithmetic, but just because you have the right answer, it doesn't mean that you're answering the question. So the check part is really, really important. Okay, so I'm glad you were able to help me with that.
Oh, and I got a great problem in my head as you were talking about division. You know how sometimes you divide and you have a remainder, but then in the word problem it's asking how many buses are needed or how many shelves. But you do the algorithm, you say, oh, the answer is 5, remainder 2. But did you answer the question? So it's always important to go back to the question and put it into context with your answer.
Yeah, because when you have a remainder, what are you going to do with those kids who are left over? Are they going to walk to the field trip or wherever you're going? So the remainders are very important as well. Okay, need to make sure you have enough. Okay. All right, so once again, if you look at the bottom of your screen, you may call us. The number is 301-772-0080.
Look, it's flashing.
It's flashing. It's welcoming you. Call us. Because what's going to happen is we're just going to talk the whole time.
And we could talk all day.
We sure can because we love math.
But we're not the stars. You're the star of the show. You're the ones that make this show happen.
Okay.
So we want to look at, look at what Miss Jax has. This looks fun. Strategies for subtracting. Oh, I gave it away. Sorry.
And you know what? I'm glad that we mentioned earlier that there are several different ways. What I'm going to do is just block a lot of this off so we can stay focused. And hopefully you all can see that on your screen. So there are several different ways to find out a difference. It's not just, 16 minus 7 equals 9. And you're not just going to set it up like an algorithm. And you know what? We use that word a lot. Let's just quickly look and see what it means when we hear the word algorithm.
That's a big word.
Yeah, algorithm. How many syllables is that? See, we're connecting math and reading language arts. Okay, so 16 minus 7. Of course, we know this is the standard algorithm. It's just the way that it's set up, and there's a process to find the answer. This one happens to be easy because it's 2 digits minus 1 digit, so we're going to get a 1-digit difference right here. So 6 minus 7. Can we take 7 from 6?
No, we can't.
Okay, so we are going to have to regroup. I know I'm used to saying borrow. We're going to borrow or regroup. So what we would do here, of course, is we would borrow a 10 and then put the 10 over here, put the 110 over here in the ones place, and that would make this a 16. And I'm not sure if students really understand that. A lot of times they're like, oh, you crossed out this and this becomes a 0. You really need to understand what that means. It means you're taking 110 from here and you're putting the 10 ones on this side, and now the 6 ones with the 10 ones become 16. So now you have 16 minus 7, and we know the answer is 9. So this is the standard algorithm.
And with our standard algorithms, we have strategies. And this one is a perfect strategy, a perfect strategy that I'm thinking of, how we can connect subtraction to addition. Because this is the algorithm, we don't have enough. But then I see a relationship with addition. If you think of subtraction as an addition problem with a missing addend, you could say to yourself, 7 plus what equals 16?
Oh.
So here's strategy number 1, here's strategy number 2. And if you can add, you can subtract. You know how many students of mine said, I can add, Miss Generette, but I can't subtract. Yes, you can. 7 plus what is 16? Boom, 9. Another strategy.
Yeah, you definitely are able to subtract if you can add, because those are inverse operations. That's another term that you'll probably hear a lot this year. So addition and subtraction are inverse operations. So we will come back to the strategies for subtracting. That is just the traditional one that you probably have seen. We're definitely going to touch on other ways to subtract. But guess what?
We have a caller.
Can I ring the bell, please? May I ring the
yes,
bell?
Yes.
Our first caller. Woo! All right. Okay, we're just excited.
All right, caller. Can you tell us your name and the school you attend?
Arnold Decker, Templeton Elementary School.
All right, so it's Annual. Hey there, Annual.
Hi.
You have a question.
Yeah.
What is your math question?
7 times 4.
Oh, wait, I'm sorry.
Hold on. Before we continue, what do we need you to do?
Because I hear a lot of feedback. I thought I was going crazy. Turn your TV down, sweetie, and listen to us through the phone. You can watch us on TV, but listen on the phone, okay?
Okay.
All righty. All right. What is your question, Annual?
7 times 4.
7 times 4.
What grade are you in?
Second.
Second grade. I just want to make
Ooh.
sure that we have all your information because your name will definitely go in our treasure box.
So, second graders doing multiplication. I'm impressed.
Me too.
Can you see the screen? There we go. So, can you tell me about this 7 times 4? Can you tell me what this 7 means?
7. What's 7 mean? 7 means like a digit of number.
7 is a number, and in a multiplication sentence, the 7 represents the number of groups. So remember how we talked about strategies? We're going to use a strategy, a very simple strategy, called drawing a picture. So our first number in our multiplication sentence is a 7. That 7 stands for the number of groups. Can you tell me what that 4 represents?
It was how much times it appears.
How many times it appears?
Well,
Okay.
how many times the group is?
You're close. That second number is the objects, the number of objects in each group. So we're gonna draw a picture to represent that. We're going to draw a picture, and then we're going to connect multiplication to another operation. That's what we're going to do.
Okay, and I'm going to ask you again, unless that's us, we're getting feedback.
Yeah.
So I don't know if that's us hearing it from your television, but did you turn your television all the way down?
Yes.
Okay. So
Okay.
maybe that's on our end. Okay.
And then we're going to figure out what's the most efficient strategy. Because I'm going to start off with the picture. This first number is a 7. So that means the number of groups. Oh, I'm hearing an echo again. I don't know if that's us or you. So I'm going to draw 7 circles. And each circle is our group.
Okay, so as Mrs. Jenneret said, we have 7 times 4, the first number here, which is actually a factor. The first factor here represents the number of groups. The second factor represents the number of objects in each group. So since Mrs. Jenneret went ahead and drew 7 circles, how many objects do you think we should put in each circle?
7 times 5 is going to equal to like 35.
Oh, you're right. 7 times 5 is 35. But let's go back to the question that you asked. You asked us about 7 times 4. So let's focus on 7 times 4, okay?
Okay.
All right. So once again, how many objects should Mrs. Jenneret put in each of the 7 circles?
4.
Very good.
Good job.
So-
You sure you're in second grade? You're doing a great job. These
I
second
don't
graders
have
are
ink.
doing an
I'll think
excellent
it-
job.
So you know what? I'm going to put stars. So we're going to have 1, 2, 3, 4. 1, 2, 3, 4.
1, 2.
Yes, thank you.
Yes, count for us, please.
1,
Thank you.
2, 3, 4. Your turn.
1, 2.
Yes. And see how this doesn't seem very efficient, does it?
Yeah,
When I say efficient, it's taking us a long time to make these circles and stars. But this is a good way to make sure we have a conceptual understanding of what multiplication means. So we're going to draw a picture. We're going to connect this to another operation. And something you did that was really interesting, you told me what 7 times 5 is. We're going to use that information also to figure out what 7 times 4 is. But let's go back to our picture. We have 7 groups, 4 stars in each group. What could we do with these 4s? Do we have to count 1, 2, 3, 4? We could.
We can just call like skip counting by 2s something.
All right, do we want to skip count by 2s?
Yeah.
You said yes?
Yes.
All right, so
2,
2.
4, 6.
Do I put the 4 here?
No, 2. 4. 4.
4 here?
No. Yes. Yes.
Uh-oh, who's that with you? Is that an older brother or sister?
No.
Okay. I like what you were doing, and then notice what I did. I put the 2 on top, And then I put the 4 on the bottom because we're still talking about that same
2 in the bottom.
group. So if we want to skip count by 2s, we can. So if I do 2, 4, what's 2 more?
6.
8, then what?
10, 12.
10, ooh, 12. We're still counting by 2s, right?
Yeah.
So I have 12. What's 2 more?
14.
14.
17.
All right, 14 plus 2 is 17?
No, 16.
16. 2 more?
What is it? 18.
Good.
20.
Good.
Good job.
What's 2 more?
22, 24.
Very good. We're almost done. We have one more group.
26, 28.
All right. We're going to stop right there. Now notice what we did. We counted by 2s. But how did we skip count on the bottom?
I skip count on the bottom because there's 4 in each box.
Very good. 4 in each box. So we skip counted by 2s because that's what you wanted to do. We could also skip count by
5.
4s.
4.
4, 8,
8.
12,
12.
16, 20, 24, 28.
Good job.
So we counted by 4s how many times? How many groups?
6.
Let's count together.
Let's count the groups.
1, 2, 3,
Is my finger in the right place?
4, 5. Ooh, 7.
There, good job.
I love that self-correction.
See how he persevered?
Yes.
He struggled a little bit, but he kept going, and then he realized what he did, and he said, oh, it's not 6, it's 7, because
Wonderful.
7 groups of 4 equals 28.
28?
And you see how we showed that with our picture?
Yeah.
We have our 7 groups, 4 objects in each group, 4, 8, 12, 16, 20, 24, 28. Do you know what multiplication is related to? Another operation?
What? Division.
Division. It is related. Oh my goodness. Are you
Absolutely
sure
right.
you're in 2nd grade? No way. It is related to division, so I'll put that up here. Division and multiplication are opposites. But there's another operation. And this, I think you'll get a lot of when you progress in 2nd grade. Multiplication.
It's subtraction.
Uh,
It's subtraction.
subtraction.
Yeah.
Well, since our number got bigger, what operation besides multiplication makes numbers get bigger?
Let me, 2.
When we had 4, we went to 8. So what did we do to 4 to make 8? Did we subtract?
What?
When we had 4 in this first group of 7, then we went, and now we have 8 in this second group of 7. What did we do to the 4 to get to 8?
We count by 4s.
We counted by 4s. Good. Did you say count or combine?
Help me. Can you help me? So? What you said? I didn't hear you.
Did you say combine 4 or did you say counted by 4?
Count by 4.
We did count by 4s. Very good. And then there's an operation we did over and over and over and over and over and over again. To get 4, if we start at 4, what can we do to the number 4? Can we subtract a number to make 8? Can we add something to 4 to make 8?
Add something to 4 to make 8.
So what are we going to add to 4 to make 8?
4.
Very good. So this is the other operation that's related to multiplication. It's addition.
4 is 8.
Yep. 4 plus 4 is 8. How do we get from 8 to 12?
How do you get from 8 to 12?
What do we do to 8? What can we add to 8 to make 12?
4.
Good job.
So 4 plus 4 plus 4. Now we're at 12. What can we do to 12? What can we add to 12 to make 16?
4.
Plus 4. 16. What can we add to 16 to make 20?
4.
Plus 4. What can we do to 20? What do we add to 20 to make 24?
4.
And 24 plus what equals 28?
4.
Good job.
Guess what 4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4 equals?
28.
28. Because we can also make an addition sentence with our multiplication sentence. Because this 7 tells us the number of groups. 4 is the number we're going to add 7 times. So if you didn't know 7 times 4, but you can add your 4s, if you take 4 and add it 7 times, you get to 28. You understand that?
Yeah.
Okay. Wonderful job.
Good job. Are you sure? I'm not sure you're second grade, though.
You're doing. If you are, you're definitely one
I
of
think
the
you're a third
smartest
grader.
second graders that we've met. But wonderful job. Thank you for persevering on that.
Yes.
And we're going to offer you to do a challenge before we go to break. We're trying to, keep in time with everything. But there are 2 challenges that we discussed when we first came on. We talked about the 24 challenge as well as the word of the day.
Okay.
So which challenge would you like to try?
1, 8, 4, and 8.
Okay. So you would like to do this challenge here?
Okay.
All right. So the digits are 1, 8, 4, 8. Make sure you write those down. And I just need to make sure we have enough time to go over this with you before we go to break. If not, we're going to ask you to write it down, and then we'll do it when we come
Yeah,
back.
I got time.
Okay.
But after this, I'm going to go to my game in school.
Oh, okay. So thank you for letting us know we have enough time. So we're going to go ahead, and since he said that we have enough time,
Yes, because
he
he's
must
in
know our
charge.
producers.
He's the star,
Okay.
isn't he? So here's our digits, 1, 8, 4, and 8. You have to make 24,
4.
and you need to use any operations. Do you have a solution already in mind to get to 20? Okay. Go ahead.
8 plus 8
8 plus 8 is?
is 16.
Very good.
Now, I'm going to cross these 2 8s out because we used them already. We may not use them again. What's next?
I got to think for a minute.
Okay.
You only have 20 more seconds to...
4
Okay.
is...
You have a 1 and a 4 left, unless you want to start over. We have a few seconds, as Mrs. Generette said before.
Start over.
You're going to start
real
over?
quick though.
Okay.
Before we have a break coming up. 1, 8, 4, 8. All right, let's rock and roll.
All right. 8 times 4 is 32.
Okay, yes, 8 times 4 is 32, and I'll just put that over here.
Okay.
All right, you have an 8 and a 1 left. What are you going to do?
A few more seconds left, and then we have to go to our break. And if you don't have it now, you can call back when you have the correct answer. A few more seconds.
I got...
You're going to call back?
Call back, yeah.
Okay, so
Okay.
you should probably still start this way and see what else you can do with those other 2 digits, okay?
Okay.
And did we add his name to our treasure chest? 'Cause he
I
did-
have his name written down. It's right here. Your name is going in. And guess what? You are the first person who called, and your name is in there. So right now, your chances of winning is definitely 100%. Okay, so make sure you call us back before you go to your game or wherever you have to go. And those of you who are watching us, the number should be flashing at the bottom of the screen any second now. There it is. 301-772-0080. Make sure you call us on the other side of the break.
Hello, my name is Jessica and I attend James Ryder Randall Elementary School. I am in the 5th grade. Today, the math problem is, during some months, Earth revolves around the sun in 30 days. How many seconds is this? Well, there's 24 hours in one day. So in order to find the hours in 30 days, I must multiply 30 times 24, which equals 720 hours. In order to find out how many minutes are in 720 hours, I have to multiply 720 times 60 because 60 minutes equal 1 hour. And that equals 43,200 minutes. Next, in order to find out how many seconds are in 43,200 minutes, I must multiply 43,200 times 60, because 60 seconds equal 1 minute. And that equals 2,592,000 seconds. So 30 days equal 2,592,000 seconds. Woo! That was a lot of seconds. I hope you found the solution to your problem easy to follow. This is Jessica from Counting Us. Bye. See you next time.
Hey you, yeah you, stay right there, I gotta tell you something. I bet you know someone with type 2 diabetes. Guaranteed, you know why? Because 1 out of every 3 little kids is gonna develop diabetes in their lifetime. That is can lead to heart problems, strokes, and even blindness. I'm John Sally, and I'm telling you, it ain't gotta be that way. Now you can up your defenses by eating more fruits and vegetables, having more vegetarian and vegan meals. These steps can be the power plays to protect you and your family against the risk of diabetes. To learn more, go to blockdiabetes.org. Okay.
He was so inspiring.
He took chances.
He was so moving.
He lived daringly.
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go. Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile. Let's smile. Let's smile. Let's smile.
Welcome back to Count on Us. This is the second half of our elementary show. I am Mrs. Jax.
And I am Mrs. Jennerette. Welcome back. And all of you elementary students out there, call us with your math work. We had a wonderful conversation about a multiplication problem and all the different representations and different strategies to solve a problem. So come and call us. Our number is 301-772-0080. It is on the bottom of your screen. Give us a call and we'll help you out.
Yes, and when you call in with a question, after we go over your math question, you have an opportunity to solve a challenge. There are two challenges. The first one that we're going to talk about is the 24 challenge, and we know that we have someone on hold, so we'll be with you in just a minute. We were working with him before the break, and he was trying to solve this one. Hopefully he has the answer to it. But this is our 24 challenge, and the way it works is that you need to use all 4 digits in just one of the cards. So let me be clear, you just choose one card, but you need to use the 4 digits in one of the cards to get an answer of 24. There are 4 different operations that you may use. You do not have to use all of the operations. And let me just clear up what an operation is. It's either addition, subtraction, multiplication, or division. You may use those in order to get 24 as your answer. You must use all 4 digits, however.
And so we have our 4 cards, and we have another challenge. 24 is a fun challenge, but we have other challenges.
Yes, we do.
We have another challenge today. Someone could actually do this one as well. Word of the day. There's a special math word underneath this lovely piece of paper. You can either guess what the word is, and we'll either tell you yes or no, and we would write it down so you can do process of elimination, or you can ask us a yes or no question in order to figure out what the word of the day is. And you know what? This is a perfect word of the day because our first caller, that word was part of our problem.
Yes, it was.
That could be a clue right there.
That was a clue. I hope you all were listening. That was definitely a clue. So I have a question about the challenges. Is there a prize if we do the challenge, or is there just a prize if we get chosen from our treasure box? We may have some students who are just turning in.
Oh, yes.
Tuning in to us, tuning in. So
what you do, if you call us with a math problem, your name goes into our treasure box. If you give us a math problem and you pick one of the problems of the day, either the 24 or the word of the day, and you get it correct, your name goes in the box another time.
So you mean that my name can go in here twice?
Yes. And conceivably, you can even get in this box 3 times.
And how would that happen?
You call in with the problem, you get a 24 challenge card correct, and you guess the word of the day.
Oh, wow. So that means that you would have 3 chances of winning. Right now, we have one person who is going to absolutely win if no one else calls in. He would have a 100% chance.
100% probability, 100%. And at the end of the show, we shake it up, shake it up, shake it up. Right now, we just have one person in here to shake up. And then we choose that person out of our treasure chest, and they get a prize.
All right.
And today's prize is wonderful.
Well, we definitely have our caller ready. And before the break, he wanted to solve card A, and the digits for that are 1848. So let's see if he is ready to solve this problem with us. Welcome back. Are you ready?
I want to change.
You want to change?
Oh,
okay,
you want to switch? Okay.
I hope you have the digits for the one you want to change.
B.
B. Okay.
B?
Well, let's look at B.
Okay.
Did you write them down?
We have the digits 5, 4, 7, and 1. And we're going to write those down. And then you're going to tell us what you are going to do with those numbers to make 24. Okay? Are you ready, Annual?
Yeah.
And
all right.
I lost sound. You can hear him?
I can hear you, and I can hear him.
Okay,
so
here
we're
we
going to
go.
move on. You have
Yes, I'm good to go.
Okay. Are you ready?
7 times 4.
Okay. 7 times 4
Equals
is?
28.
Oh, that was smart. Good job.
You just solved that one. All right.
All right, so we used the 4 and the 7.
8 minus 5.
Say it again.
28 minus 5.
28 minus 5 is what?
It's 23.
All right, he sounds excited.
Oh, we're close. And then what else?
23 plus 1.
23 plus 1 is what?
24.
Yay! You get the bell. You got the bell twice.
You sure did.
Yes. And guess what that means? You get your name again in our treasure chest. So how many times are you in our box?
2.
2 times. All right. And I hear the excitement. I heard the excitement when you said 7 times 4. You know that 7 times 4 is 28. I bet you will never forget that. So good job on that. And let's look at the operations that he chose. He definitely did multiplication, he did subtraction, and addition. So remember, the 24 challenge, you have 4 operations you can use. You do not have to use all of them, but he did use all 4 digits. And a lot of times the challenges have different ways to solve it. So if you're a viewer out there and you want to call back in and try card B, or you want to try card A or C or D, and one of the callers have already, solved it, there are different ways to solve. So it doesn't mean that this is the only way. Just think about, what other ways you can use those 4 digits to come up with 24. So thank you. I'm so
job,
excited.
Annual. Who is your teacher? Let's give that person a shout out. Annual?
Yes.
What's your teacher's name?
Miss Barrett.
Miss Barrett. Good
All right.
job,
You
Miss
give her
Barrett.
a high five
Yes.
from us to her because you did a great job.
And looky, in the treasure box you go.
Ooh, twice.
Woohoo.
Okay.
All right, thank you.
Okay.
Have a good day.
All right.
Make sure you call back on next Monday. Wednesday.
Wednesday.
Today's Monday.
Because we come on twice a week.
Yes, call back on Wednesday. Okay.
All right. So we have strategies for subtracting.
Yes,
We're
we
just
do.
doing all kinds of things today. We were talking about our problems, our mathematical practices. We talked about multiplication strategies. Now let's go back to subtraction.
Okay. Now, before Annual called us, we were talking about 16 minus 7 equals 9. This is the traditional algorithm that you're probably used to, your parents are used to, the algorithm we are used to. But now with our new curriculum, the Common Core State Standards, there are so many different ways to arrive at your answer. Well, there always have been different ways, so now you're able to use any of those ways to get to your answer. And of course, this one, since it's subtraction, your answer would be a difference. So different ways to find the difference. What we're going to talk about today is place value. And I know my viewers out there, especially 3rd, 4th, and 5th graders, have been working on place value. You worked on it in Unit 1. Some of you were still working on it in Unit 2, especially those 5th graders. So let's talk about place value. Let's decide how we can use place value in order to find out the difference of 16 and 7. All right, so what we want to do here is first look at our minuend. First look at our minuend. Let me get my terms correct. Okay. First look at the minuend. The minuend is the large number that you're subtracting from. Okay. So let's look at this. This is 16. Well, what I want to do is look in the ones place. May I have red or blue or thank you. So the ones place, has a 6. And then the tens place has a 1. What I want to do is pull out all of the tens first. And I think that'll be easier. So if we look here, how many tens are in the tens place?
We have 110.
We have 110. Okay.
And that makes
10. Well, I also have some ones left over here in the ones place. So I'm going to put plus 6. So 10 plus 6 gives us 16. And we do see that we have a caller.
Yes.
We will actually continue this in just a minute. But hopefully you get the idea of what we're doing. So you take the 16, you can break it apart by the 10s and the 1s. We will definitely get back to that. But we want to honor the time of our callers.
Yes.
And we want to thank you, this student from Mount Rainier. Thank you for calling in. How are you and what is your name?
I'm good. I'm Cheyenne.
Hi, Cheyenne. How are you?
I'm good.
Okay, Cheyenne, are you in 5th grade?
Yes.
Now, how do you think I knew that you were in 5th grade? I don't even know you, but I mean, I see Cheyenne's in 5th grade. She's calling from Mount Rainier. How do you think I know that you're a 5th grader? Do you have any idea?
No.
What is your question about?
I know.
It's about volume.
About volume. The reason I know is because 5th grade is definitely working on volume. So that's how I know. Okay. All right. So tell us what your question is.
It says its height is 2 feet, length is 3 feet, and width is 2 feet.
Okay, so before we continue, I'm going to ask you to turn your television all the way down and just listen to us through your telephone, okay?
Okay.
All right, so go ahead and turn it down because what's happening is I can hear myself in your house. And there's a delay and it's just distracting us. So we want to make sure that when you listen to us talking to you, you can only hear us through your telephone, okay?
Okay.
All right. Did you turn it down?
Yes.
All right, thank you. So I heard you say the height is 2 feet. Is that correct?
Yes.
All right, and then what was the length dimension for the length?
It's 3 feet.
3 feet. Okay. And then the width. And what is your width?
It's 2 feet.
2 feet. Okay. So we definitely have all 3 dimensions here for volume. What I'm going to ask you is, I want you to tell me what you already know about volume.
That we have to multiply length times width times height.
You are so smart. Okay, so you're right. We are going to multiply the length times width times height. So it says here, now let me ask you this because you gave us the height first and then the length and then the width. Let's talk about the commutative property really quickly. Does it matter if I multiply the height first times the length? Does it matter which order I multiply these?
No.
No, it doesn't. You're absolutely right because there's something called the commutative property. With addition and multiplication, it does not matter. You're still going to get the, for multiplication, you will still get the same product. And with addition, you're still going to get the same sum. So what I want to do is go ahead and multiply 2 times 3 times 2. Okay? Cheyenne?
Okay.
Okay.
3 times 2 is 6.
So 2 times 3 equals 6. Absolutely right. So 2 times 3 is 6. We already multiplied the height times the length, so I'm going to cross these out. And what's left over? Cheyenne, what other dimension do we still need to multiply?
6 times 2.
6 times 2. Okay. So 6 times 2 gives you what? What's your answer?
And 12.
12. Now, is this it? Is it just 12, or do we need to include something else?
You have to put feet.
Good. I have feet. There's one more thing that I need to do. What else do I need to include after feet?
Like, do we have to, when you get the answer for 6, why, like, do you have to multiply by 2 to get the answer for the whole?
That's a good question.
Very good question.
Well, now, I'm not a good artist. I'm going to try my best to draw. Okay, so let's talk about volume for a minute. Volume means the amount of space inside of, well, this particular one is a rectangular prism, okay? So it means the amount of space that this prism can hold. And you said we have 2 feet. Feet is the height, so 2, oh, my marker. Thank you. So 2 feet, that's how tall it is, okay? And then the length, how long it is 3 feet. Oh, and we have a model here.
A model.
And then the width, this is actually even better because, you know, it's 3D and we're actually holding it and we can turn it around. So let's look here. We have a length of 3. 1, 2, 3. Okay? You see that?
Okay.
And then we're going to go this way. We're going to go across, which is the width. We're going to see how wide it is. It's 2 cubes wide. Do you see that?
Yes.
Okay, so now Mrs. Generette is going to turn it just a little bit so you can see how high it is.
Whoops.
Okay,
Oh.
and then it's a height of, I know it's kind of hard.
It's weird.
We can see it, but if you turn just like that.
Okay.
Now, even though we're showing you this, this is the height. Okay, she's going to turn it back at some point. But the height is just 2. So we have 2 cubes times 3 cubes, which is the length, times 2 cubes, which is the width. With something that's 3-dimensional, there are 3 dimensions. There's a height, a length, and a width, okay? And volume, like I said, is the amount of space that something can, oh, she's going to break it apart so you can see.
Yes.
So the amount of space that would fit inside, or the amount of space available, okay?
So if we look at this rectangle right here, we have a length of 3. Let's do the width. Width 2. 2 times 3, the length is 6. If we do 2 tall, we have the 6, and then if we make this times 2,
so it will be like another layer.
Another layer.
Let's
so
do
what
them
I'm going to
separate.
do,
And then we'll put them together.
and here's one of those great ways where you can model and show another way. Another 2.
Maybe if we turn it this way. I hope you can see it better this way. Can you see that?
Can you see our cubic units?
Okay, and Cheyenne, we're going to ask you to turn your television down because we can hear the feedback.
And when you count all the cubic units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I think you asked earlier, why do we have to take the 6 and multiply it by the 2? It's because we have another layer that's 2 square units tall. It's so hard to do the...
Yeah, it's really hard to see that. But that's good because one of your standards in 5th grade is definitely to realize that volume is additive, meaning that, like with Miss Generous going to take it apart, one layer is 6 cubic units, but if you put another one on top, if you make it 2 units high, then it's going to be 6 plus 6, which gives you 12. So it's definitely 12 units cubed, and this is what I wanted to ask you about. We have feet, but we're going to put a little 3 here, and this 3 is actually an exponent, and it means cubed because we're multiplying 3 different dimensions. So we have 3 times 2 times 2, which gives us 12 feet cubed. Does that make sense to you, Cheyenne?
Yes.
Okay, I hope we helped, and we have a lot of people on the line. My goodness, where were you all the first half of the show?
We only have a few minutes, but we'll get to as many people as we can, and then those who don't get through, stay on the line because we have our next session.
Yeah, I wanted to ask Cheyenne. I guess she hung up. I was going to ask her if she wanted to do a challenge.
Sorry, Cheyenne.
I see a student from my school, Hillcrest Heights. A shout out to Hillcrest Heights. Okay. We may not get to you, Layla, but I'm glad that you did call. So make sure you call back on Wednesday if we don't get a chance to get to you. It looks like we only have time. I'm hoping if our producers say yes, we may have time for one person calling from Templeton. So the caller from Templeton will be our last person. But guess what? The show continues from 5 to 6. So hold on, Layla and Kara and Felicia. Hold on, and your questions will be answered by our expert mathematicians from middle school.
Yay.
Okay, so we're going to quickly answer this question from Salma from Templeton Elementary. How are you?
Good.
All right, quickly give us your question, please.
48 times 12.
Ooh, oh. There's so many
You're
different ways.
excited.
I love math.
We only have time for one way.
Oh. Well, what method do you want? Because we could do the standard algorithm. Do you know another method that you want to use?
No.
Okay, you want to do the standard algorithm?
We promise the next time we're on, we're going to show you another way.
And
But
the other
we have
way,
like 1 minute to go.
It's so cool. But yes, all right. Oh, I can't. Oh, I'm just
do you
so
think
upset.
we have time?
Let's do it this way.
Okay.
We'll have time, and I'm going to show you another way, and hopefully 48 times 12. Can you write 48 in expanded form?
Yes.
40 plus 8. This is called an area model. So I want to make a big old rectangle to show my area model. And then I have 12, which I can break down to 10 times 2.
All right.
So 10 plus 2, I'm sorry. What's 40 times 10? Oh, 45 seconds. 40 times 10. Do you know what 4 times 1 is?
Yes.
What's 4 times 1?
4.
And then how many zeros?
1.
This 0 over here also, so it's going to give us 2.
2 zeros.
We're just going to show you at this point.
10 times 8 is 80.
Yeah,
so
10 times 8 is 80.
2 times 40 is also 80. And 2 times 8 is 16. So now we have area models. And what we're going to do, these are our partial products. We're going to take each partial product and we're going to add it up. 8 plus 8 is 16, plus 1 is 17. I bring the 1 to the hundreds. 1 plus 4 is 5. Guess what? 48 times 12 equals 576. And I'm so upset that we took so fast. But Layla, you're going to call back so we can get this area model.
Yeah, call back with the middle school experts. They will definitely go over the area model with you. And we want to thank everyone for watching our show today. We're going to quickly choose somebody. So Selma and our caller from Templeton, actually they're both from Templeton.
Oh, wow. Cheyenne is our lucky winner.
Cheyenne
from Mount Rainier.
Cheyenne from Mount Rainier, you are the winner for today.
Yay.
And we apologize for having to rush.
Everybody called at the end.
Yes.
Next time, call at the beginning.
Stay on the line. The middle school show is coming. We see you, Layla and Kara and Felicia. Stay on the line. But you can always count on us.
Hello, my name is Mrs. Sun, and I'm here with today's mini lesson on perimeter. We're going to talk about what perimeter is and the difference between area and perimeter. Today's objective is to apply measurement concepts in order to determine perimeter. Perimeter is when we are finding the distance around a shape. So very often when you're reading a word problem, you're going to look for clue words, such as border. Sometimes you're going to be finding the border of a bulletin board or a room or an area. You might also find the word fence a lot, because remember, these are things that go around something. So remember that we are looking for keywords that help us know that we are finding the distance around a shape. So let's talk about how to find perimeter by using this word problem. Riley is making a bulletin board for her classroom. The board is 7 feet by 9 feet. She needs to add a border around the entire bulletin board. What is the length of the border she will need? By knowing that we are finding the border around, we know we're going to find perimeter instead of area. So to do that, we want to add all of the sides together because we want to know what the distance is around the whole thing. If there is not a shape in the word problem, or if they're not showing you the shape, go ahead and draw it. So here we know that we have this area that is 7 feet by 9 feet, and we want to add all of the sides. However, all of the sides won't always be labeled, so go ahead and label the other sides. Remember that for a rectangle, opposite sides are the same length, so this would be 9 feet right here, and this would be 7 feet. So we want to find the distance around, so we're going to add them all. Two ways to do that. We can add 7 plus 9 and then add that twice. Or we can add 9 plus 9, which is 18. 7 plus 7 is 14. And put those together, which I'm going to do. Either way works. 8 plus 4 is 12. 1 plus 1 is 3. So it's 32 feet is the border. So remember, for perimeter, we are going all the way around. Now, real quickly, I want to talk about the difference with area. If we were finding the area, we multiply length times width to find the square units inside. So be careful not to do that with perimeter. Multiplying gets you those square units inside. For perimeter, we're finding the distance around, so we want to make sure to add all of the sides. Now, let's take a look at a little bit of a different perimeter problem. This is from mdk12.org. The perimeter of the figure below is 80 inches. What is the length in inches of the missing side? So we know that they all need to add up to 80. So what I first want to do is I want to add the lengths that I know. So we're going to add those together real quick. I know that 6 plus 4 equals 10. 5 plus 7 is 12. 10 plus 12 is 22. So I'm going to carry that up. 22. 2 plus 1 more, 3, 4, 5, 6. That is 62 inches are all of these sides. The whole thing adds up to 80, so I want to find the difference between 80 and the sides we already have, 62. So I'm going to subtract. I cannot take 2 from 0, so I'm going to go ahead and I'm going to regroup. 10 minus 2 is 8. 7 minus 6 is 1. So this leftover side is 18 inches. And to double check, what's really important, if we had time, we would do that today, is to add all of the sides and check that it equals 80. So remember, perimeter is the distance around a shape, and you add all of those sides to find the perimeter. My name is Mrs. Sun, and that is today's mini lesson on perimeter. Have a great day.
Minds can achieve anything. We make sure they get to college. Federal student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
Because how many ways are there to solve math?
Many! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is
2 times length plus 2 times width.
Hey, welcome back. We're to stay tuned to our TV show, Count on Us. This is the intermediate version, the upper grade, the high level stuff, the big time. Time for you to ask some good questions from Count on Us TV show personalities. My name is Ted Herman.
And I'm Miss McCants.
And you're at what school?
Gwynn Park Middle School.
Oh, that's right. You're the Gwynn Park Connection.
That's right.
And you're over there, all these great 7th and 8th graders learning all the high level skills.
6th graders too.
6th graders too?
Yep.
Beautiful.
Mm-hmm.
And what's our number on the TV show you can call us at?
301-772-0080.
Right. If you missed your lovely words, it's right on the bottom of your screen if you're watching TV. And also on the World Wide Web, they can go to www.pgcps.org
Mm-hmm.
and then go to the webcast and follow us along on your computer screen. And do we have any challenges today, Ms. McCants?
We do actually have a word of the day. And we also have our 24 challenge. There it is. So A is 9 with a dot.
Oh,
with a
yes,
dot in.
right.
3, 2, and 14. Card B is 1, 5, 4, and 7. Card C, you can't see the C, but it's C, 7, 6, 8, and 2.
Mm-hmm.
And card D is 5, 2, 8, and 8.
She nicely puts, she points those numbers out so beautifully. It's like watching Vanna White on Wheel of Fortune. But these 3 dots right here,
that's right,
to me is a little tougher kind of problem. So make sure when you call in, you have tried all 4 numbers to total up to 24 using multiplication, addition, subtraction, division.
And the 1 dot means it's the easiest.
Ah, right.
And the 2 dots are
in the middle.
In the middle.
Okay, Goldilocks.
Okay.
And the word of the day.
And our word of the day.
Oh.
No one has tried the word of the day.
Nobody's tried the word of the day?
No, so I hope someone calls in for it today.
Well, we'll give you hints. I want to give the first hint on word of the day since nobody's tried it yet. And it has something to do with math.
Well, that's what this show is all about.
Yep. I didn't want to give it away, but it has something to do with math. So hopefully that helps all the people start thinking about what to do for the word of the day. Hey, I think we have our first caller, Miss McCants.
I do believe we do.
And
who is this?
Well, you know what? If that's on the air with Montana, that's my
Montana.
student from Mount Rainier.
Really?
I would love to talk to Montana. Hey, Montana.
Hi.
Hey, turn your TV all the way down, Montana. Good to see you. Hi to you. And turn that TV volume all the way down so I can hear your lovely voice. Because you're one of my top fourth graders this year at Mount Rainier Elementary School, Montana.
Yay.
All right. And do you have a good problem for us today, Montana?
What do you think?
Do you have a problem for us today?
Yes.
Okay, what's your problem?
It's about division.
Really?
Yes.
I like division. What about you, Mr. Herman?
It splits me up.
So what's your problem, Montana?
352 divided by 23.
Okay, hold on right now. Now, Montana, I think you're one of my greatest students. I really love you. Last year, she's in the Christmas play for the school, the winter pageant. But we haven't taught that. Why would you ask that? Are you trying to embarrass me in some way? No, you wouldn't do that. Okay, what was the numbers again?
You said what's the problem with it?
Yes,
I'd love
what
to
is
hear
the
number
problem?
again, yeah.
352 divided by 23.
352
divided by 23.
And that looks like that. Well, Montana, since you're such a wise, gifted student, so sharp with your skills, let's break this sucker down and divide. The divisor is 23, and if you don't mind, I'm going to round that off or estimate it to 20. All right? And if I cover that up, it makes our job a lot easier. But if I cover up the ones here, I'm going to cover up the ones in 352. Well, I'm not going to get that far. I'm going to start right here. So, Montana, how many times can 2 go into 3? How many times can you fit a 2 inside of 3?
1.
Oh my gosh. But we're using right here for our main answer, okay? So we're not just dividing by 2, we're dividing by 23. So 23 will fit into 35 one time because Montana said so. And if Montana says so, I know it has to be true. So then 1 times 23 is?
23.
Excellent. And then we do the operation of subtraction. And let's go ahead and do that for me, Montana. What's 5 minus 3?
5 minus 3.
I asked you first.
2.
That's my girl. And 3 minus 2?
1.
Right. Now, can 23 fit into 12? Is that going to fit?
No.
No. So we have to go over here to the 2 and bring that down. Who's that in the room with you? Is there somebody in the room with you?
Yes, it's Daddy.
Who?
It's Daddy.
Daddy. Well, Daddy? That's your daddy? Oh, wonderful. Okay. So now with 23 divided into 122, we're going to try the same process again. We're going to cover up the 3 and the 0 there and cover up that 2. How many times can 2 fit into 12, Montana?
6.
Outstanding. But I can tell you right now, if it was just 20 we're dividing by, that'd be the right answer. It'd be perfect. But 23 is bigger than 20, so let's not use 6. Can we use something a little bit smaller that'll fit?
Mommy, I'm going to do all the lessons.
Okay. Well, what's lower than 6? Instead of using 6, we're going to use...
What's right under 6?
5.
Excellent.
Excellent job.
Because we use 6, I can show you right now, we're going to be over the 112. 6 times 3 is 18, right, Montana?
Yes.
And then you carry the what?
1.
Thank you, Miss McCann.
You're welcome.
And then 6 times 2.
12.
Ah, and then the 1 on top makes what? Not 12, but...
13. 15.
That's my girl. And you can see 138 is way too big for 122. So that's why I wanted to go use the 5. So, oh my gosh, she can read my mind, which is very easy because it's kind of empty. But anyway, let's try the 5, Montana. Show everybody on TV what a great mathematician you are, multiplying. What's 5 times 3, Montana?
15.
Thank you. Put down the 5, carry the 1. 5 times 2?
10.
And then one more.
11.
And that will fit. 115 will definitely fit inside the 112. Do you know how to do 2 minus 5?
12.
We're going to borrow.
We're going to borrow. Make that a 1. Make this a what?
7.
12 up top. And 12 minus 5 is 7. And then the 1s are all not going to work with each other very well. They're already 1 minus 1 is 0. So we have a remainder of 7. How do you say the whole answer, Montana?
15, remainder 7.
Wow.
Excellent job, Montana.
She's getting her name into our treasure
chest. Yes, she is. I have already written it up for you, Montana. I'm putting it in right now.
Montana, you want to try the 24 challenge problem, or do you want to try the word of the day, or are you done for a while? You want to try challenges?
Yes.
Which one? I love your attitude.
Do you want to do the word of the day, or do you want the 24 challenge?
What's the word of the day?
Okay.
Okay, Montana, how about you call us back when you make up your mind which one you want to do? You can give us a call back, okay?
But I'll give you 5 eagle eyes tomorrow for calling in the show and keeping my job alive.
Hello?
Hello?
I want to try word of the day.
Okay.
Can you try word of the day? Is that okay, everybody? Let's try the word of the day.
Okay.
Okay, I'll give you one more hint. It's something to do with math, and it has something to do with numbers.
Math and numbers.
Digit?
Digit.
Can you just give us your best guess? We'll give you yes or no.
She said digit.
Oh, digit. I got to say, it is something to do with digits. I'll have to give you a yes on that. Now, do you want to guess the word real fast? We have a lot of callers, Montana, so give us your best shot. It is something to do with digits.
What did you say?
It is something to do with a digit of a number. It's a word we've gone over in class, so give it your best guess.
So why don't you think about it and give us a call back? Okay?
Okay.
All right.
Okay.
We'll talk to you in a few minutes, okay?
Okay.
All right.
She got her name in the box.
And her name is in the box.
Oh, great.
Excellent job.
Nice job. Your caller's up.
Hi. Who am I speaking with?
I'm speaking with Fabiola.
Sabiola. I love your name. That's very pretty. Sabiola, what school do you go to?
What?
What school do you go to?
I go to Scotchtown Hills.
You go to Scotchtown Hills?
Yes.
What grade are you in? Who's your teacher?
My teacher is Miss Radford, and I am 6th grade.
You're in the 6th grade. Excellent.
Is that
Welcome
Laurel?
to Count on Us.
Is that school in Laurel? I apologize.
What?
Is your school in Laurel?
Yes.
Okay, great. Welcome to Count on Us. I'm Miss McCants, and this is Mr. Herman.
Oh, Scotchtown Hills?
Yes. What's your...
Oh, my gosh. I've never been there, but I'm happy you're there.
Sabiola, what's your question?
I am having trouble with mental math.
Okay. Mr. Herman is also having problems with mental math.
Among other things.
So what's the question?
It says 20% tip for a $30 meal.
What's that?
Read it one more time.
20% tip for a $30 meal.
20% for a $30 meal?
20% tip for a $30 meal.
20% tip for a $30 meal.
Yes.
Okay. What are you supposed to do with this problem?
I didn't hear you.
What is it that they're asking you to do?
It says use mental math to find each percent of a number.
So you're going to find 20% of $30?
Yes.
Okay. Mr. Herman, do you want to set this up as a ratio? Do you know anything about ratios, Sabiola?
Yes.
Okay, what do you know about ratios?
Well, ratios.
Do they compare numbers?
I didn't hear you.
I said, do they compare numbers?
I still didn't hear you.
Okay, well, Sabio, let's look at it like this. If we take the 20% and break it into 10%, 2 sets of 10%.
I can't hear you clearly.
Are you watching TV, Sabiola?
No.
Oh, that's the problem. Well, let's just go ahead and try to work this for you and lead you through without you even actually seeing what we're doing. Because we're doing mental math anyway.
Okay.
So
we're going to talk about 10% of the $30. So if we broke up the $30.
And you know what of means in math? Multiplication. 10% times $30. So where does that lead us, Miss McCann?
Well, we have to first change this percent to a decimal.
I got
by dividing.
So let's slide this up and make that. And you really could put 0, decimal point 10, times the $30.
10 times $30.
Not 10, but 10 cents. It would
Right.
be 10 cents times $30.
So if we do that mental math right now, 10 cents times $30, where does that take us?
Will give us what?
It would give us $3.
Excellent
Oh my
job.
gosh.
Excellent job.
That's terrific. I'm really impressed.
Me too.
And then we do it.
We're going to do it one more time.
We're going to do this, you know what I'm talking about? We're going to do this again. My tongue got away from my mouth for a second. So we have how much again, Saviola?
Okay.
10 cents times $30 again. What did you say for the first answer? I forgot.
She said $3.
Ah.
So it has to be $3 again. You checking behind our mental math?
So Samuel, if you have $3 twice, how much does that give you total for the tip?
So you have $3 twice. You get $6.
Excellent job.
And that'd be a nice tip in the restaurant. It would show the waiter or waitress you really appreciate their good job they did for you.
So 20% tip, go back to the original question. Our 20% tip on a $30 meal would give us how much?
$6.
$6. Saviola, you're very, very smart. Very, very smart.
I'm sorry to butt in, but can I add to that?
Sure.
What would you actually pay?
What would be your total?
Your total bill with the cost of the bill plus the tip put together.
$36.
Oh my
She's
gosh.
on it. She is on it.
Goshtown Hills is really proud of her.
Yes. Saviola, I'm going to put your name in the treasure chest.
Okay.
Oh, you already did it?
For you, I'll do
High
anything I can to make
five.
you happy. There you
High
go.
five. So it's a team here.
We're a team.
Saviola, I put your name in the treasure chest so that you can be entered in winning a prize at the end of the show. Did you want to try a challenge?
No, thank you.
Okay, well, thank you very much for calling us, and tell your friends to call us on Wednesday.
Nice job. Very proud.
Okay?
Okay.
Have a good day.
You too.
Got some very smart students in Prince
Yes.
George's County school system, I'll tell you.
Mm-hmm.
Our next caller is already waiting for a long time. That must be Cameron?
Yes?
That's your name, Cameron?
Mm-hmm.
What school do you go to, Cameron?
Huh?
What school do you go to?
Problem?
No, she said, what school do you go?
Maulia Elementary School.
Okay.
Oh.
Cameron, can you turn the TV down a little bit for us?
Yeah.
I mean, turn it all the way down so you can't hear anything. Just talk right into the phone.
There you go.
It is.
Okay.
It is what? It is what? It is
Okay.
what it is. I hate that expression because we can always do better than that. We're always going to try our best to overcome all the odds and get on that playing field and win the game. So talking about the game, what's your problem today, Cameron?
2/3 divided by 5/6.
What's that? I couldn't hear you, Cameron.
2/3.
Two-thirds? I haven't taught fractions yet to my class. This is amazing.
2/3.
This is amazing.
Divided by.
Divided by?
Mm-hmm. Divided by 5/6.
Oh, you have complex fractions.
I'm telling you, who's in the room with you, Cameron? One of my top 4th graders this year. Who's in the room with you, buddy?
Okay.
Good. Okay. Well, I haven't really taught fractions, but I'd like to give it a shot because the first fraction, the 2/3, we don't bother with that. We leave it alone. Because we're going to change this problem from division into multiplication. Yeah, yeah. Okay? I don't know why I'm doing that. That's embarrassing my whole family. But what's 2/3? What's the opposite of division, Cameron?
Division?
What's the opposite?
Times.
I love it. And if we do a times, we're going to flip this up and call it the reciprocal. Reciprocal. We flip it upside down. So what do you have? Not 5/6. You have what?
6.
6/5. I love your style. And your moms, whoever's in the room with you there, giving you good help in there.
Yep.
And we're all one big team helping each other through life.
That's right.
So now you could go ahead and multiply, or you could do cross cancellation. Let's do the multiplication and I'll show you the cross cancellation later. What's 2 times 6, Cameron?
12.
That's one of my leaders of his math facts. 3 times 5.
2.
3 times 5.
15.
15. But you can't leave a fraction like that because it's not simplified. You got to get it lower than that. So watch this. We're going to lower it down, and whoa, we're going to lower it down. Bless your heart, Miss McCann.
Mm-hmm.
And take that 12. Hi, how are you doing? Good to see you. I'll bring the groceries home later, but oh, I'm scared. I'm on TV right now. My bad. Okay, so here you go, 12/15. We're going to take 12/15, and do you know a number that can fit into both 12 and 15 at the same time? Any small digit?
3.
3 is right, Cameron. You are terrific. What is 12 divided by 3?
What's 12 divided by 3?
4. 4.
Yes. Tell Makai is doing a good job, too. 15 divided by 3.
Oh, Jesus.
I knew Makai was with you, your brother. 15 divided by 3 is what?
5.
There you go. And that would be your lowest term simplified answer. And just to show you 4/5 again real fast, if everybody doesn't mind, I'm going to take the 3 here, and I know 3 fits into itself once and goes into 6. How many times does 3 fit into 6? The same 3.
3 times 6?
I mean, how many times can you fit 3 into 6? Divide 3 into 6.
2 times.
2 times. And what's 2 times the 2 we have up top? 2 times 2.
4.
4. So I'm putting that right over here. And what about the 5 and the 1? 1 times the 5.
5.
Is right. So we got the same exact answer without doing a lot of extra breaking it down at the end. But either way is right. Did you want to try the challenge today, Cameron? Because your name is already in the bucket one time. 24 challenge or word of the day?
Challenge.
24 challenge.
I love it.
He's great. What a good student he is.
Okay, the 24 challenge. Which one would you like to do?
Which one would you like
A, B, C, or D?
Got it.
Oh,
Which one?
A.
A?
No.
It's 1, 2, 3, and 4. I mean, A, B, C, or D.
A is an apple.
You want to try D?
D?
Which one you want to try?
Why don't you ask your mother what she wants to try? She can pick any one she likes too. I don't care what letter you pick. But who? D?
Yes.
As in dog.
5, 8, 8, and 2.
5, 8, 8, and 2. You know what, Miss McCann? I'd like to give you a chance to try that yourself because you're so good at it. You want to try that?
I'm waiting for Cameron to try it.
Okay, I mean that's right. Right. Go ahead.
Cameron, you ready?
Yes.
Okay, let's hit it.
5 times. Wait, which one?
You gotta. Everything has to equal up 24.
Yes, 24. I'll put it over here. 24 is what you're trying to get.
24 is what you're trying to get, Karen.
So 24. 5 times 5. No.
You can only use 5, 8, 8, and 2.
And only one time each number.
Only one time.
5 and 2.
You try. Look what they're saying.
Cameron, you know you can call us back after the break. Write down the numbers.
I'll call you back.
Okay, write down the numbers 5, 8, 8, and 2. Work it out and call us back in about 5 minutes, okay?
Okay.
All right, we'll talk to you in a little bit.
Are we saying we're going to a break now? Is that what I heard?
I think that's what we're doing right now.
That's right. That's
Take
what
us
I
to
heard,
break,
too.
Mr. Herman.
Okay, time for a break because we want you to call back with more of your math questions right after these messages from our break.
Hi, I'm Cameron from Samuel Ogle Middle School. Today's email question is from Nicole at Benjamin Tasker. Nicole says, my problem is 98 hundredths times 7 3/10. I don't know where to put the decimal after I multiply. Help! Well, Nicole, first you do basic multiplication. You do 8 times 3, which equals 24. You drop your 4 and carry your 2. Next you do 3 times 9, which is 27, plus 2 is 29. You drop your 9 and carry your 2. Next you do 3 times 0, which is 0, plus 2 is 2. Next we move to the ones column. Now we do 7 times 8, which equals 56. You drop your 6 and carry your 5. Next we do 7 times 9. 7 times 9 is 63. Plus 5 is 68. You drop your 8 and carry your 6. Next we do 7 times 0, which equals 0. Plus 6 is 6. So now we add. For a placeholder, we add a 0. 4 plus 0 is 4. 9 plus 6 is 15. Drop your 5, carry your 1. Next we do 8 plus 2. 8 plus 2 is 10, plus 1 is 11. You drop your 1, you carry your 1. Next we do 1 plus 6. 1 plus 6 is 7. Now we look at the problem. We see that a decimal comes before 3 numbers in this problem, which means in the answer you bring the decimal over 3 places and you get an answer of 7 and 154 thousandths. Well, Nicole, I hope that was helpful. That was the email question of the day, and I'm Cameron Jenkins from Samuel Ogle. Bye.
time to get to know people, and you'll see that all of these labels are false. Don't let prejudice shape your view. Stereotyping is wrong, and it hurts all of us.
Stop stereotyping.
A message from your American Muslim neighbors.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly. I wanted to be a cowboy. Tom Cruise in Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
Hey, welcome back to the second half of the intermediate show, Count on Us. And we're ready to answer all your questions, your challenges of the day, whatever you desire. We'll try to make sure you get your name in our drawing. And our drawing is always something good to eat, you know what I'm saying?
Yeah, it's always sweet.
Just like my partner. And I think it's your time to have a call.
Okay.
Isn't that amazing?
We're back on with Montana.
Oh, I love Montana.
Montana, are you ready?
Montana's back? Great.
Montana, are you there?
Yes. I have the word of the day now.
Okay, you're on the word of the day. Here we are. Ready?
Yes. I think it is multiply.
She says multiply, Mr. Herman.
Well, you know what? I have to give you a yes on that because that's a good. I can't give her a no for real. That's not the word, but you're in the ballpark.
That is not the word. Do you think she's in the ballpark? I would put that as a no.
Okay, I'll give you a yes and a no. Because Miss McCann said no. Now, if it's a yes and a no, has something to do with multiplication. I got it. Not the word multiply, but multiplication. So I'll give you a hint. What'd she say?
She said it is a yes. We can cross off the no.
Okay, very good. So we got overruled by the official judges.
That's right.
In California who called in just now, and they watched the show regularly, and they had to disqualify the no and give us back to a yes.
That's right.
Way to go, Montana. And can you think of a word that means you multiply numbers, a digit, to make a product? What are those words called?
Addition.
Oh, that is in the multiplication family, but that is not the word. No
more hints.
We cannot give you any more hints. Montana, you got to try to call back if you think you know it, or you can call back with the 24 challenge. I'm going to put the card back up for the 24 challenge.
Okay, that's fine.
Okay.
All right.
For the
thanks
second
for
half,
calling in again.
Here we are. So here are the numbers. Write down which card you would like to try, so you can get your name put in the treasure chest again. So
B.
Okay, card B. This is 7, 6, 8, and 2.
No. Wait, what did you say?
7.
Oh, this is B over here.
Oh, I'm sorry. 1, 5, 4, and 7.
Is that what you're talking about?
Is this
yes.
one?
Montana?
Okay. 1, 5, 4, and 7.
So you're going to write those numbers down and then get back to us in a few minutes?
Yes.
Oh, great, Montana. We'll be right here, and we're waiting for your phone call.
That's right.
Because I'm very lonely with that phone call, so thanks for calling back soon and give us a good answer. Oh, my goodness. It's a student from GPMS.
That's right.
That sounds like some kind of cool acronym for a really cool place to teach.
It is a really cool place to teach, and I have really cool students. Is this Cameron?
Yes.
Hi, Cameron. Who's your math teacher?
Mr. Kate.
Who's your math teacher?
Mr. Kate.
That's right. It's me. So what you calling about today?
That's sad you didn't know who his math teacher was.
Ratios and percent.
Okay, so what exactly is your problem? Because Mr. Herman is going to help you.
What?
$1,500 at 9% for 3 years.
Oh, so what is the question?
It says find the amount paid for the loan.
Okay, so you're talking about interest? Simple interest? Okay. So what is the question again?
$1,500 at 9% for 2 years.
Oh, okay. So we're writing down some important information.
Okay, $1,500. I got that first.
$1,500 at 9% interest.
Yes.
Watch this.
And turn your TV all the way down so we.
Sign, isn't that cool? At 9% interest.
Turn the TV all the way down. Just talking to the telephone. And that's at 2 years? Over 2 years?
Yes, 2 years.
Okay. So is there a formula that we could use? I'm helping you, Mr. Herman.
I'm hoping Cameron's got that formula too.
How about I? Start with I.
I
equals
what?
P R T. I equals PRT.
What do those letters stand for, Miss McCants?
We're going to talk about that.
Oh, okay.
I is representing the interest, and I think that's what Cameron is trying to solve for.
Oh, yeah.
And the P is going to represent our principal amount.
Yep.
Okay, and the R is going to be the rate, the interest rate, and T is going to be the time represented in years. Okay? Cameron, you with me?
Yes.
So we're going to identify that $1,500 is going to be our P. $9% as our rate, but when we are looking at this, what is going to be our operations, PRT? Because I don't see any symbols here. And Mr. Herman is putting parentheses. What's going on with, what kind of operation are we doing?
Multiplicative inverse.
Not multiplicative inverse, because we're not flipping anything, but we are going to do what?
Multiply.
We are going to multiply. Excellent job. Okay, so now Mr. Herman is trying to help you out here. He's saying that we need to change our 9% to a...
to a decimal.
That's right, to a decimal. So 9% written as a decimal would be what?
0.9.
Close. It would be 900ths.
Oh, 900.
900. So that means we will have the decimal, 0, and a 9.
Ah.
900ths. That's how we call it. How we say that in decimal. Okay, and our 2 years.
Yes.
And our
200.
Well, we're just going to put 2 years straight up, right?
Because it's already in years for us.
So, if you don't mind, Cameron, we're going to go ahead and put this in the calculator. $1,500 for principal times 0.09, you so beautifully said before, times 2 years gives a grand total of 270. What does that 270 represent?
What are you trying to solve for?
The interest.
Okay, our simple interest. Now go back to the question.
270 what, though?
Yes.
Octopus, squids, undersea divers?
Go back to that question. What is the question asking us for?
Find the interest of the find the interest of the percent.
Oh, okay. So what would be the units? Are we talking about?
It says find the amount paid for the loan.
So 270 pennies or $270? Which one would you say, Cameron?
$270.
Right. Please don't use the word "and" unless you have a talking about cents left over, like $270 and something cents. Okay, so then Miss McCants would tell you to do what with that 270 and the 1,500? How much was it going to cost you total for this loan? What are you going to do with these two numbers?
Total, what do you need to do? What does total mean?
The grand amount.
Okay, you have the first amount, and what are you going to do with the second amount?
Multiply it.
Why are you multiplying?
Because you have to find the the amount paid, and there's a percent sign.
Mm-hmm. But why are you? I think you're multiplying because you like to multiply. He's talked about multiplication the whole time that we've been talking to him. When I hear the word total, what does total mean? If I have $1,500 as my principal, and they're telling me that I'm going to also have $270 interest, what should I do with these two amounts for total?
Divide them.
Really?
Add.
Okay, why?
Because you're asking for the grand total. So.
Exactly, Cameron. I'm glad that you thought about it and you persevered.
Mm-hmm.
And now Mr. Herman is telling us to take $1,500 and add $270 to that. Did you put that in your calculator, Mr. Herman, or are you going to do it the long way?
I'll do it the long way real fast. But she also showed us academic rigor. Okay, so $1,500 plus the $270 for the interest. And what does that give us? Can you do that mentally? Okay. Or we can just go ahead and thank you.
Mm-hmm.
Let's go. Zeros and zeros are zeros. Another zero here. How about 0 and 7, Cameron?
Cameron, you still there?
Yes.
What's 0 plus 7?
7.
What's 5 plus 2?
7.
And what's 1 plus 0?
1.
And that's, how do you say that whole number for your amount that you owe for this?
Cameron?
Yes.
What's the amount that you owe?
$1,770.
That's right, $1,770. Did we help you out a little bit?
Yes, you helped me a lot.
Okay, great. Did you remember to write down the formula because you have to show your work?
Yes.
Mr. Herman has already wrote your name, and we're going to put it in the treasure chest. Stick around to see if you are a winner, okay?
Did she want to try a challenge today at all, or did she say that?
Did you want to try a challenge, Cameron?
No.
Okay. Well, I'll see you tomorrow, okay?
Okay.
And you're definitely going to get those 5 buzzing bucks. Thank you.
You get 5 whats?
Buzzing bucks.
Buzzing bucks. And what's your school mascot or whatever, your symbol?
The yellow jacket.
Oh, buzzing like a bee.
Yes.
Bucks.
Bucks.
Cool.
Who do we have next?
I don't know.
Cameron?
Cameron just was on the air.
That's another Cameron. This is your Cameron from
This
Mount
is
Rainier.
my Cameron. K-A-M.
Cameron, you're back.
Yes.
Which challenge did you have? You had the 24 challenge, right?
Yes.
And you had letter B?
No, you picked D as in dog.
D as in dog. Okay.
Oh, right.
D as in dog. We're talking about
the hardest one.
5288, right?
Oh, I got that. 5288.
Or 5882. That's how we wrote it for him the last time. Come on, Mr. Herman. 5882.
Well, if we're that good in math, we can be able to do it any
old way we want.
Any way it's coming to us.
Mm-hmm.
All right, Cameron, show off your brilliant genius.
I did not get 24 for the answer.
You ready?
You got to give us the steps.
I did not get 24 for the answer.
Oh, you didn't do 24.
What'd you
I
get?
didn't get it.
What'd you get?
I got 23.
Well, this is called a 24 challenge, not 23 challenge. If it was 23 challenge, we would have called a different game altogether. Let's see what it says right here. It says 24 challenge right there.
I tried.
Well, Cameron, do you want another card? We can give you another set of numbers so you can try those.
Okay.
Well, what is the hardest group?
You pick the hardest card. Pick another one.
No, B as in boy.
B as a boy.
Okay, so you're going to write down the numbers 7, 4, 5, and 1. 7, 4, 5, and 1.
And work that up till you get 24, and then call us back. Okay? Because we have a little bit of left time. What? Okay?
Okay.
Call
All
us
right.
back.
So we'll talk to you in a few minutes.
Looking forward to hearing from you, Cameron, and the whole family. All right. Oh, my goodness. Look who's back on the air.
Montana, you made it back.
Yes. I'm ready to see the challenge.
You did the 24 challenge as well?
Yes.
Okay, so I'm going to put the cards back up here. Which numbers did you try?
B.
B as in boy?
Yes.
1, 5, 4, and 7, right?
Oh, boy.
That's the one?
Yes.
All right, let's hit it.
Oh, let's not hit it. Let's just do it. I don't want any rough stuff here. Okay. What are those numbers again? 1,
5, 4, 7.
You say nicely. You say numbers very beautifully. 1, 5, 7, 4.
Yes.
All right. And this is Montana going to nail the challenge.
All right, let's go. Which one did you do first? Which two numbers and what operation?
7 times multiplication.
Okay, 7 times what?
7 times 4 equals 28.
7 times 4 is 28.
Gotta be quiet.
This is my first show ever.
Okay.
Exciting.
And
Oh, wait a minute.
So we're going to cross off.
Cross it out. Oh, she's so good. You got a 1 and a 5 left.
And 28 plus 1 equals 29.
Oh, I didn't see that coming. Nice job. So we're going to cross out the 1 over here.
And you said 29?
Yes.
Okay.
You have a 5 left.
And 29 minus 5 equals 24.
Give that bell a ring. Give that bell a ring. Yeah, Montana,
baby. Oh, wait a minute. You're making Mr. Herman about to jump out of his seat.
I'll tell you, I'm jumping for joy. That's my Montana.
All right, Montana. I'm gonna write your
goodness.
name down. You persevered. You called and called and called.
Not only she persevered, she tried
Yes.
hard too.
Yes, you
I'm
did.
really proud of her. My goodness, Montana.
Montana.
Oh yeah, I knew she was going to do something great.
And she's doing it right here on this show. So I'm going to put your name in one more time in our treasure chest. So now you have 2 opportunities to win the secret prize at the end of the show.
Oh, my heart is beating big for Montana. Oh my goodness.
Thank you.
Thank you.
You are so welcome.
I'll see
Thank you for
tomorrow
calling.
in school. I'm going to be so proud of you.
And make sure you call us on
Always.
Wednesday.
What?
Okay?
Call back on Wednesday?
Wednesday.
Well, she has a long wait. She'll be sitting by the phone the whole time till Wednesday. That's a
Well,
lot
she
to
gets to
ask.
see you tomorrow.
Oh, that's okay. I'll see
right.
her too. Okay, I think it's your call.
Okay, who's next? Zoe? Is that you?
Yes.
Hi, Zoe. How are you?
Yes.
How are you doing?
Good.
She's very short in her words. You ought to see her in class. Zoe, that's my Zoe. My 4th grade Zoe I love. But you got to say more than that. What school you go to, Zoe?
Mount Rainier Elementary.
Oh, and who's your math teacher this year, Zoe?
Uh-oh.
Mr. Herman.
Oh, is this Mr. Herman?
And are you learning this year?
Yeah.
Zoe, I'll give you 5 eagle eyes. Turn your TV down, Zoe, so you can hear us talking to you, okay, sweetheart? All right. Can you give us a good problem today, Zoe? We're dying to hear your Zoe problem.
My problem is 12 times 6.
12 times 6. Did you teach this?
That's awfully easy, but I did teach that sort of one time.
Times.
Maybe the first day of school or something. I don't remember.
12
times
6.
6. Wow. Okay, Zoe. That looks pretty good. A little below your level of intelligence. You're a lot smarter than 12 times 6. And actually, I like to call it 6 times 12 because which one is the multiplier here? Good. So we're going to start with 6 and go 6 times 2. What do you get for that, Zoe? Good. What is 6? Yes. What do I put down here, Zoe?
The 2.
And
the 2.
What do I do with the 1?
put it over, you carry it over the 1.
Outstanding. Thank you, Zoe. 6 times the 1 over here makes what?
What's 6 times 1?
6.
6.
And then we do the 1 on top.
What do you do with the 1 on top?
You add it with the 6.
Yes.
Excellent job.
And what do you get for that, Zoe?
What's 6?
7.
Yes. So what's your final answer?
72.
Oh, yeah.
Wonderful.
Oh, yeah,
Wonderful.
Zoe. You're getting your name in the box. I'll tell everybody on the air that Zoe went to the University of Maryland this past weekend with her dad, and she came back a lot happier about University of Maryland. She wants to go there someday, right? As a student, maybe? So her name goes, what?
She said yes.
Oh, yes. Good, Zoe. Did you want to try a challenge while you get your name in the box over here for a treasure chest? You want to try a challenge? 24 challenge or a word of the day?
Okay, which one would you like to try? The 24 challenge or the word of the day?
The word of the day.
Okay.
Oh, I bet she has it.
And while
She's
you're
really
working on
good.
that, I'm going to go and put your name in the treasure chest, okay?
Fantastic. And do you have a guess for our word of the day? I was told no more hints. No more helps. Something to do with multiplication and single digit.
Is it factors?
Give me the
Is
bell!
it factor?
Give me the bell!
Yay! It is factor. Wow. Factor. Uh-oh, wait a minute,
Zoe.
wait a minute. Zoe, you showing off today. You are just throwing your name in that treasure chest.
Way to go,
Excellent
Zoe!
job.
Zoe! You know-y. Yes, you do. Oh, my goodness. I'm really proud. Look at those great students.
I know. And they're in your class? Okay.
Yes.
So come on, we have other callers.
Yeah, other
Zoe,
callers.
thank you so much for calling.
And we're back to you. Who's next?
Who's next?
Is that Caitlin?
Caitlin. Caitlin?
Yes.
Caitlin who?
Parker.
Hi, Caitlin Parker from Glen Park Middle School.
Isn't that sweet?
You called me.
Yeah.
So, what's your question? We have to hurry.
I'm trying to hold your
Running
excitement
out of
down.
time.
You're a
I
little
am.
too
I'm going to hold it down. I'm
enthusiastic.
going to hold
She's
it
a
down.
little- I'm talking to Caitlin. She sounds very excited about the whole thing.
Caitlin, what's your
It's kind
question?
of like Cameron. It's kind of like Cameron.
Okay, it's kind of like Cameron's. What is the question?
So it's 4,800 at
You right?
9.9.
4,800?
4,800 at 9.9.
10.
9.9% for 2 years?
For 4 years.
9 9/10%. Thank you. 9 9/10%.
So is this right? Can you see it?
No, it's not on my TV.
Oh, okay, I'm sorry. So you have, what about now? Can you see it now?
Yes.
Okay, so you did say it was similar to Cameron's. So we're going to use the same simple interest formula. I equals PRT. And we're going to identify each part. So 4,800 will be the principal or the P.
I'm working it up right now.
And then we will have our 9.9% changed to a decimal.
So what would that be?
It would be 99 thousandths.
Times 4 years.
Times 4 years.
Gives us a grand total of $1,900.80. And what we're going to do with that, Caitlin, as far as the original $4,800 invested?
You add?
Going to add that together. Her name's in the box.
Her name is in the box.
And
I'm shaking it
now-
up. Okay, Mr. Herman, you take your take the name out.
I'm picking
Hurry,
a name out, and our winner today, we all had winners out here, and that is Zoe! Mount Rainier! And you can always count on us. Yeah, baby. Yeah.